Hello and welcome back to the Inside Java podcast, the podcast about everything Java brought to you by the team at Oracle that builds Java. My name is Nicolai Parlog. In this episode of Ask the Architects, I talk to Daniel Fuchs and Daniel Jelinski, both consulting members of technical staff at Oracle and OpenJDK committers, about HTTP 3 support in Java. We start by briefly retracing the steps of the HTTP API introduced in Java 11 and its support for HTTP 2 before diving deeper into HTTP 3 to learn about the motivation, technical underpinnings like the QUIC protocol, and challenges for its adoption before discussing its integration into Java 26. We occasionally mention the related JDK enhancement proposal, JEP 517, which is linked in the show notes or otherwise on inside.java/podcast. Enjoy the episode. We did have the capability to connect to things online in Java for a long time through URL and URL connection, all that good stuff. And then I think in JDK 11, there was the HTTP client introduced. And if I'm not mistaken, you were involved in this, right?
Oh, yes. I was involved in the standardization of the HTTP client in the JDK 11, but it was first pushed into JDK 9 as an incubating module. And that was the first time that an incubating module was used in the JDK. So that was an interesting experience. And
okay.
So when we standardized that in JDK 11, the advantage is that we had the opportunity to change a few APIs.
Yeah, I was going to ask. So you took the opportunity to make some changes based on the feedback?
Not necessarily based on the feedback, but we improved the API. We improved the usability, I think, between 9 and 11. I don't remember exactly what we changed. And we also, we probably changed some of the internals as well.
Okay.
And of course, we improved the test base between 9 and 11. So there was a refresh in 10, which was still incubating, and then we had the final version in 11. The main advantage that the HTTP client brought compared to HTTP URL connection is that the HTTP client is a more modern API, that it uses Builder to build the client, uses Builder to build the request, for instance. It allows you to choose many different implementation of body publishers or body handler, depending on where your source for the body or your target for what the target for your body is. You're not bound to use input stream and output stream like with HTTP URL connection, which to be fair, for some is a bit of an issue because they used to use output stream and input stream. They have an infrastructure around that provides output stream to write request to, or that needs an input stream to write the request from. So we had to provide a body handler, for instance, that would return an input stream so that people could read from the input stream instead of streaming it from the Flow API. The Flow API was a big thing at the time. It was the Java interface that model reactive streams. And so most of our body handlers are under the cover are reactive streams. So you can provide a body handler that is a subscriber. So you can use the Flow subscriber interface to request data from the client, but I don't think many people use that.
I think it's a power user niche case, right? For situations where the body is really large and you just want to process on the fly. And I think it's something that if you need that case and you don't have it, it's a really big problem. So it's really good that it's there. But I think, most people will just, I write demos, not really code, right? But I use body handlers of string like 95% of the time.
Yes. And so the main feature of the HTTP client is that it added support for HTTP 2, which HTTP URL connection didn't have. And also there is support for WebSocket. Although I'm not sure the WebSocket API in the HTTP client is used very much. We had one or two bug reports along the years, and I think that doesn't mean that this is without bug, but rather that this hasn't been used as much as the other parts. One of the other decisions we made for the HTTP client, which I think was very good, is that we don't have a static pool of connection. So connections are not shared between clients, like HTTP URL connection has this hidden pool behind the scenes. And it begins difficult if you have several independent parts that runs in the VM, because they might share something for these pools that are shared. So with the HTTP client, each HTTP client has its own pool of connection, and so if you create an HTTP client, it's completely independent of another HTTP client that you might create for another part of your application.
Yeah, and if I remember correctly, you can also configure that, right? Like you can configure the pool, for example. I think generally, as you said, through the builder pattern, you can configure. Like most of these things work well again for demos out of the box. Like the default settings are there, but you can go in and for each client, or even request each, pick certain things that are then different per request, and configure all of that.
Yeah, well, we are supporting both HTTP1 and HTTP2. We have a pool for HTTP1 and a pool for HTTP2, and these pools are completely different. And this is because when you use HTTP2, you usually make a single connection to the server, because HTTP2 supports multiple streams on one connection. So you can have multiple request response stream on the same connection. And so the HTTP2 connection that are in the HTTP2 pool of connection are connections that are alive, right? Whereas the connections that are in the HTTP1 connection pool are connections that are idle. And as soon as you use the connection, you take it off the pool, you execute the request, and you put it back in the pool. That's how HTTP1 works. But that's not how HTTP2 works. In HTTP2, the first request that comes for a given server will create an HTTP2 connection. That the HTTP2 connection will be put in the pool, and then it will stay there until the idle timeout expires. If it becomes idle at some point, there is a possibility to set up a timeout so that the connection will get closed, or until the server sends a go away and asks us to close the connection.
Yeah, that's already foreshadowing something that we're going to get to pretty soon, because as a user, the difference between HTTP1 and HTTP2, I mean, despite like the behavior of the protocol itself, but as a user of the API, the main difference is, well, I just pick the enum value, and all the complexity you just described is hidden from me, right? Like that's really comfortable for me as a user. It's just like that sounds like a you problem that you have to solve there.
Yeah, exactly. And it's the same for HTTP3. I mean, it's almost the same, and we will get to that later. But if you want to send a request for HTTP3, you just set the request version to HTTP3, and the client will do its best to honor that version and try to use HTTP3. But the rest is almost completely transparent.
Yeah. Before we get to that, though, I have another question. Although there's still like a little bit of the historic part on the HTTP client. So as you said, like the old way to do this with URL and connection, it was HTTP1 or 1.1, I think. Was the when the new HTTP client was created, was the only motivation for that that a more modern API would be good, or was it also that the old model just didn't map onto HTTP2? So was there only, I would say in quotation marks, a usability motivation, or was there also a technical motivation? No, we need to do a new client because the old one just wouldn't work with HTTP2.
I think it would have been much more complicated to update the old client to HTTP2. I would consider it legacy code at the moment. When you want to send a request, there is this giant method that does everything and everything, and it's a bit hard to maintain. And also the HTTP2 URL connection supported thing we we didn't want to support a new HTTP client, like support for NTLM, for instance. It was possible to have a request cache. It was possible to have, response cache. So there were lots of functionality that we thought would be better handled by the application itself, that would use the HTTP client rather than handling them ourselves. Because when you handle them yourself, then you make choices, and everybody have to abide by these choices, right? You no longer have the flexibility of doing what you want.
Yeah, that makes sense. That's the issue, right? Like if you want to make those decisions, you either, as you said, like you make those decisions and then users have to abide by it, or you just make everything configurable, which makes it like easier for bugs to crawl in, and specifically something that connects to the network. I would guess that bugs can also always be vulnerabilities, which is probably something you'd want to avoid. So I can see why simplicity maybe is more helpful here.
Yeah. So with the HTTP client, if you want to cache response, it's your responsibility as an application to cache the response. So you would have to put something on top of the HTTP client. Maybe you could wrap the HTTP client that the JDK provide into your own instance of HTTP client that under the cover calls the JDK one, and then that does the caching if necessary.
Yeah, and I guess it really helps that requests and responses are both immutable, which is really, I think, as I said, like a more modern API that is really helpful, right? You can, like, if I have a recurring request that is complicated to create, although that's a little bit of a, artificial case, but still, technically, I could just, create it once and put it somewhere and keep reusing it. So that's really, really handy, I think, that all those types, well, the request and response at least are immutable, or at least the important parts where you send them to the clients. So should we go to HTTP3? Should we discuss? So here's how I started, how the idea for the podcast came around for this episode specifically is that we had an internal conversation, me and other people on the team, and I was like, well, the HTTP3 stuff is kind of boring because look, all I have to do as a user is change the enum value. And, of course I can, talk to people about that in minutes. And then there's a few other details that are worth discussing, but it's not like it's not that big of a thing, right? It's just like, we support HTTP3 now. Isn't that good? Everybody nods their head and thumbs up. It's good. And then we're all happy and move on. But then I was basically yelled at by a colleague. Was like, no, this was a huge pull request. This was so much work. You're undervaluing all that work. And I kind of felt bad about it. So I looked into it a bit. And so I thought, there's actually more there than meets the eye, which is really interesting. So let's talk about that a little bit.
If I had to briefly summarize what HTTP3 is, I would say that HTTP3 is like HTTP2 over QUIC, where QUIC is a new protocol that was introduced to solve a few issues that TCP has. And QUIC, if I had to summarize it, I would say it's TCP plus TLS over UDP. So
someone who's not steeped in network terminology, I have to struggle to put those terms together to make sense. Can we go into a little bit more detail? So what was the motivation there maybe for this change? Why HTTP moved away from TCP?
Yeah, so the motivation for this change was mostly to solve the head of line issue, where if you have a packet, that IP packet somehow gets dropped by the network. With TCP, you have no choice but to wait until that packet has been retransmitted to continue. Because TCP just sees all your multiple requests that you might have made through HTTP2. It just sees that as a single stream of data. Whereas with HTTP3 provides the multiple stream of a single connection. So each stream can in fact be handled separately. It means that if a packet that contains data about one stream is dropped and it needs to be retransmitted, all the other stream can continue. So this will not block all the requests that have been made to that server. It will just block the request for which some data was contained in the packet that was lost.
Performance was the main consideration when implementing HTTP3, or rather when developing HTTP3. So the idea was that there's a limit of how fast you can get the first byte of a response with HTTP, well, the classic HTTP, because first of all, it costs one round trip to just establish the TCP connection, then it takes another round trip to establish the TLS, and only then you can send the request. That was improved, so you have like 3 round trips before you get the first byte. With TLS 1.2, 1.3, actually, it was improved so that one of those round trips was removed, but it was still like, 2 round trips before getting the first byte of data. And with HTTP3 and QUIC, you can actually send the request in the first batch of data and then get the response, as soon as the server can respond, which is basically as fast as it goes.
Yeah.
Yeah, and there were also other considerations like TCP is actually hard to evolve. There are those ideas that how people could improve TCP, but TCP is ossified. You'll find that term in many of the documents about QUIC. So basically, if you want to make a change to TCP, you cannot just say that now TCP behaves like that. You have to update all the routers, all the network machinery out there, before you can take advantage of those changes. And that's a problem. And with QUIC, basically, the data that is exchanged is opaque to those network devices. They cannot see what's in there. Everything is encrypted, so they cannot interfere. So any evolution of QUIC will only happen on the endpoints, on the applications that are talking QUIC to each other. So between the client and the server, only the client and the server can affect the traffic.
Yeah, that also actually answers another question that I had, which was, because I found it curious as somebody who studied computer science like a while ago, let's say about 20 years ago. I learned about TCP and UDP and the difference between those. And I learned, okay, so TCP is for like established connection where every piece of data is important, every package needs to arrive, blah, blah, blah. And UDP is more like a fire hose, more like fire and forget, just like this for streaming media and stuff. That's what I learned. And so I found it really surprising to learn that HTTP3 uses UDP, because when I was taught this back in the days, and I was a student, so I probably got the simplified version, but that simplified version was very much, this is more for potentially unreliable data streams where a missing package is not the end of the world, which, general HTTP connections do not sound like that. They sound to me like, no, generally speaking, if I have ask my front end, ask my back end for the data the user requested, it sounds like all of that should arrive, really. So I found it surprising that the underlying model switched from TCP to UDPs. And you're saying that the reason maybe for that was the lack of evolvability of TCP? That's interesting.
Yeah, so with TCP, the data can also get lost, but any data that is lost is retransmitted by the operating system. And the retransmissions follow some semantics that is well known to all routers out there, and it cannot change. And with QUIC, the same you can also lose data, and the same retransmissions are done on the QUIC layer. But since everything is encrypted, then no one knows if some data is actually a retransmission or if it's a new data. Especially since the packets are never sent exactly the same. So even if we retransmit some data, we still give it a new packet number, encrypt it afresh, and so it's from the network perspective, it's basically a different packet.
Yes, one of the reasons this HTTP3 PR was so big is that there have been a number of RFCs that we needed to implement. So there is one RFC to cover the part of QUIC that will not change if the QUIC version is updated. There is another RFC that describes QUIC in itself. That's RFC 9000. There is another one that is called QUIC TLS, and that describes how QUIC uses TLS secure connection and encrypt the data. And then there is another RFC which covers congestion control for QUIC and how a congestion controller would work. And then we have the RFC that describe how HTTP3 makes use of QUIC to send HTTP requests. So it's almost the same as an HTTP2, but the difference is that HTTP2 defined the notion of streams, and the streams were a HTTP2 concept that was transported by TCP. Whereas with QUIC, because QUIC has the notion of streams, then HTTP3 can directly make use of this QUIC stream. So HTTP3 doesn't really need to have stream because stream are provided by the QUIC protocol. And then there is also RFC for QPAC, where QPAC is an evolution of HPAC. So HPAC is for header compression. So HTTP2 uses HPAC for compressing headers, and QPAC is basically the same, but it describes how this is used over QUIC streams. And QPAC is very much more complicated than HPAC because HPAC was practically synchronous. So the instruction to compress headers were directly sent in the stream that carried the headers. Whereas with QPAC, it's different. The headers are carried with the request response stream, whereas all the synchronization that is needed between the two peers in order to be able to compress headers are carried by independent streams that are the QPAC streams, and which makes it much more complicated to implement. And then we also have HTTP alternate service that we have implemented. We also have implemented another RFC which allows to negotiate QUIC versions.
The way you describe it sounds to me like it tries to capture the moving parts in this more like on a more isolated level. Is that also done to like allow the evolution to allow more evolution in the future? Because then, as you described, that TCP is kind of ossified. Is this an effort to try to prevent that from happening for QUIC, so that from the beginning it's clearer which parts can evolve and potentially how?
Yeah, so there was the first RFC that described the changes, the things that will not change between QUIC versions. So QUIC invariance, and yeah, that part is not going to change, but everything else is subject to change. And QUIC version 2 was actually defined very different from QUIC version 1, just so that again, network does not ossify on QUIC version 1.
So does Java's HTTP client and all the routers still need to speak both versions, right? Because when a new version of QUIC comes out, like it might take a while before the network infrastructure all upgrade to that version. So that means you need to always maintain like all the versions?
Right. So the idea is that every machine should speak QUIC version 1. That's one thing. And the routers do not need to speak QUIC. They just need to understand UDP. So they will not ossify on QUIC. They only need to understand UDP.
Oh, that makes sense. Okay, right. The layers.
Yeah. And in order to use QUIC version 2, both ends, both the client and the server need to speak QUIC version 2. But as long as they can agree on one version that they both support, everything will work. Yeah.
Okay. So it sounds like you had your work cut out for you on the number of RFCs there. So that explains the big amount of work that you did. So how long did it take, like from wanting to do this? Because as I said, like I think as a user of Java, it landed quite atomically, right? There was like one JEP that said we support HTTP3 now. Boom. How long did it take you to get there?
I'm not sure.
So what do you measure? Like, was it like a 6-month project or like a 3-year project? Like roughly, you should know, right? Like amount of...
It was more like a 3 years project, maybe a bit more.
Okay.
Obviously, we weren't working on that full time because we'd also had to maintain the other APIs. There was bigger projects into which we were pulled at some time or another. But yes, it started when I started working on this. QUIC was still in draft. It was not, the RFCs had not been published.
Okay. So that means that Java really is an I'm not sure whether early adopter, but at least like we're early in the game of supporting HTTP3 then, I gather, right?
Yeah, we were not the first, but yeah, we are early.
Yeah.
Yeah.
Okay, nice. It doesn't happen often with Java. I'm kind of proud of us. Well, of you guys, I didn't do anything. That's like being like, it's a new feeling. Is that what it feels like for other people, like on the cutting edge? It's weird. It's good. Okay, so let's talk about HTTP3 in Java. As I already alluded to a couple of times, the absolute minimum that somebody needs to know to get started with this is basically nothing, right? Like if you just want to make like the smallest amount of things you need to know is like just change the enum value when you pick the HTTP version, and then it might already work, right?
Yeah. So one difference with HTTP3 compared to HTTP1 and HTTP2 is that there is no standard port defined for HTTP3. And that might seem surprising, but a server can very well support HTTP3 on a different port than 443, which is the standard TLS port for HTTP. In practice, I'm not sure whether many servers make use of that. I would expect that most of the public servers would support QUIC on the same port than they support regular HTTP. But it means that because QUIC and TLS are two different transports, it was no longer possible to negotiate which version is supported by the server using ALPN, which is the standard way you can negotiate with the server using TCP, whether the server supports HTTP1 or HTTP2. So that cannot be used for HTTP3 because the transport is different. So you cannot switch a TCP connection to use UDP.
Yeah.
Yeah, that's it's a different handshake. So one way that was advocated in the HTTP3 RFC was to use HTTP alternate services. So you would first make an HTTP request to a server using TCP, and the server would respond with some with an alt service header, basically telling the client, "Oh, by the way, I'm supporting HTTP3 on this port." And then the next request could go through HTTP. And so that's one of the ways we support HTTP3 in the HTTP client, is by supporting this HTTP alternate service RFC.
Yeah.
Another way you could do is the optimistic way. You could say, okay, I'm making this request, and the caller tells me that he wants to use HTTP3, and maybe the server, which is at the other end, supports HTTP3 on the same port than it supports HTTP. So I'm going to attempt to make a connection using HTTP3 and see if it works. And if the server doesn't respond, then it means it doesn't work. And I'm going to fall back to regular TCP in that case.
Yeah.
And for HTTP client, we thought, well, if the caller asks us explicitly to make a request through HTTP3, then maybe we should make the effort to send the first request through HTTP3. And so we have this implementation where we're going to send a QUIC packet to the server, the first initial packet, and we're going to wait for a little while for an answer. And if we get no answer, then we will switch to TCP. That's in the case where we don't know whether the server supports HTTP3 on this port or not.
Yeah. To reiterate, just like, so the complexity comes from, unlike with HTTP 1 and 1.1 and 2, you cannot just reuse the connection upgrade. So you need to, like, the process is more complicated. So you need options, right? Because there's no clear one best way to do it. And you described two so far, right? You described the one where the server, like, you ask the server what you speak, and then you get, but that's an extra round trip, right? You just ask the server, and then it tells you what version and where. So that adds a round trip that, as Daniel just described, this protocol worked hard to reduce the number of round trips, and now you add one to know whether you can speak it. So that's not ideal. But, it might be the choice that you have to make. And then other what described is just like, you either know or just hope that the other server speaks HTTP3, and then you initialize the connection with that. But then you have to wait for a timeout, right? Like, because maybe there's no way that the server speaks HTTP3 and then responds, but I don't speak HTTP3. So all it does, it's probably going to time out. So you have to wait for that. Yeah.
Yeah. And so that's the reason we have added this new API to set HTTP options on the request. And at this moment, we only have one HTTP option. It's called H3 discovery, and it can take 3 values. It could be alt service, alt SVC, which tells the client you should use alt SVC. So if you don't know if the server supports HTTP3 or on which port it supports HTTP3, then do a first request using TCP and wait until you receive this alt service header or alt service frame for HTTP2. And then you can switch to HTTP3. And then there is the HTTP3 URI only, which means we're going to use the host port, the authority, the host port information, the URI, and we'll make an HTTP3 request at that URI. And if there is no server there, then we will fail. So we'll only do HTTP3. So that's the case where there is HTTP3 and you want to talk HTTP3, right? And then there is the other optimistic case, and we call that any. So we will first try HTTP3. If you instruct the client to use HTTP3, we'll first try HTTP3. If after a reasonable timeout we have not heard back from the server, then we will fall back to TCP. And that's one of the reasons we decided not to make HTTP3 the default protocol in the client. It's because there are trade-offs. First, if you want to do HTTP3, you have to open a UDP port. If you don't intend to use HTTP3, right, there's no point in opening that port.
Yeah.
If you and also if you attempt this HTTP3 connection, then there is this little timeout that you need to wait for before deciding no, HTTP3 is not the right thing. We'll use HTTP2. Or you could make 2 connections, but then you make 2 connections, and what do you do with the other one? If one succeeds first, what do you do with the other one? Do you keep it? Do you throw it away? So there is a cost, right?
Yeah. As you said, like, if there's a trade-off, then there's often a situation where it doesn't make then it's harder to pick a default, right? Like, it's easy to pick a default if it's just better or just works in almost all the cases. But if it's a hard choice, then it's not ideal to make a default. So is there a hypothetical future, I guess, right? Where everybody's where the vast majority of servers just speaks HTTP3, and then in the future that could become a default, I guess, right?
Possibly, but then there will still be a slight incompatibility risk, because in the HTTP response, when the response comes, we have an API to query which version was used. So you can check whether HTTP1 or HTTP2 or HTTP3 was used. But before we implemented HTTP3, this version is an enum. It had only 2 values, which were HTTP1 and HTTP2. And now it has a 3rd value. So if you have code out there that was compiled with the previous version of the JDK, where the version has only 2 values, and then suddenly it sees the 3rd value that it doesn't know about, then it will throw an error, right?
Yeah, but that is already the case, right? That is already the case today. So I could already today have code running that. Oh no, well, it can't happen because without make HTTP3 the default, I will never get 3 as an answer, right? I will.
Yes.
Okay, yeah, that makes sense.
Yeah.
Okay, so if you make it the default,
someone
then,
has to opt in at some point to
maybe another way to make
receive
it default
an HTTP3 response
would be like on a with something. I'm just spitballing here, but something like command line flag, right? But you like where it's still something that you can apply globally to an application, but where you still have to do at least a minimum amount of work so that you can do due diligence before, figure out that no, my code and my dependencies work with HTTP3, and then you can activate it globally, so to speak, for your application instead of having to walk manually through every connection and set it there.
And the 3 modes of operation were very important to us when we started developing tests. Because in tests, it's not real life, right? You are in a testing environment, and you have plenty of tests that run on the same machine. And this plenty of tests start up plenty of servers. And if one server use one port for QUIC and one port for TCP, and another server use one port for QUIC and one port for TCP, then this port could be cross-reference, right? You could have one server using one port for TCP and port 2 for UDP for QUIC, and the other one using the same 2 ports, but in reverse, because they appear free for that version of the transport.
Yeah.
And so at the beginning, we had some tests randomly failing because we were using any, and so the wrong test would connect to the wrong server because everything was running on the same machine. So it's important to have this ability also to decide which mode you want to use, and especially if you are using Java to write some kind of test in a test environment where you could have this strange server deployment.
Okay, interesting. Yeah. But I have another question about discovery, though. I know that you can discover this via DNS, right? I think that's a possibility, and I also think that Java currently doesn't do that. Why am I right that it could, and am I right that it doesn't? And then the question would be why?
Yeah, because it's so the answer would be because it's recent. I think that RFC, which is called service binding and parameter specification via the DNS.
Yeah.
So it allows you to require resource record to request resource record, and that this resource records could contain information that this host supports this version of HTTP at this port. And it's relatively new. I think it became standard in 2023.
Okay.
So yeah, it's 3 years ago, but
yeah,
it's still kind of new, and so we haven't started implementing that yet. There's also the question of where would this make sense, because at the moment we have iNet address, which handles all the queries to the DNS server. And how would we get that information from iNet address, right? It would need iNet address. Well, the way we do queries to the DNS would have to change, because instead of or in addition to the regular DNS query, we would have to make a query to get this resource record. You cannot do that in the same query. You have to do 2 parallel queries.
Okay.
What kind of API would we have to provide this functionality? So we're not using that, and maybe that's something we should think about in the future. Yes, why not?
Yeah. Okay, but so it's good to hear that you're saying like there's no fundamental reason why Java couldn't support this. It's just, as often the case, it just requires an amount of engineering work that just needs to become a priority at some point for it to be actually done.
Yeah, and it needs to be, and of course, any new work needs to be motivated, right?
Yeah. Yep.
We need to have motivations, and we need to write a JEP, and then we need to implement the JEP, and and also every time you add new APIs, then it's a new maintenance burden because you have to maintain this API.
Yeah, that's a good point. Like, it's as you described, because it uses another. So init address that you described is also a public API, right? So changing that means that it needs to be changed in a backwards compatible manner. It needs to always be maintained from there on out. So it would basically expose that functionality to users, which just heightens the hurdle for any kind of work within OpenJDK, right? Because like if it's only internal, it's easier to get an API in than if you want to make it a public API that needs to be supported for basically forever. This might also be the answer to the other question that I got on social media actually the other day. What about exposing QUIC? You made a QUIC implementation clearly, or rather, Java speaks QUIC now, but that is hidden as an implementation detail. Do you know of any plans to make that public?
No, that's definitely not on the roadmap. It would be a very huge project, and I think the API surface would be relatively significant. Yes, so it's not something we would do lightly, and at the moment, it's clearly not on the roadmap.
Okay. As I said earlier, as I said in the beginning and a couple times in between, the API surface change is kind of small, so that's cool. I think that's great that users can somewhat easily adopt this, but it's not without requiring some background understanding of the trade-offs that you described between how do I actually figure out what the server speaks the version, and if I have control over both servers, maybe in like a microservice environment, I think that's pretty straightforward. But if I talk to the real world out there who have not control over the opposing server, or not opposing, the other server, then the user should know about these trade-offs, and they are described in the JEP, right? The JEP, I think, if I remember correctly, goes into detail on this discovery. Yeah. Okay.
Yeah, and Chai Kiranpai also wrote a very good article which has been published on dev.java.
Okay.
And which explain how to use the HTTP client to send HTTP request and the different choices that you have with this discovery mode.
Okay, cool. Yeah, I'll make sure to find that and put it in the description on whatever platform all of this ends up. So yeah, that's good. Thanks for the pointer. Okay, then thanks again, both of you. And I hope I didn't take too much of your time so that you can still be productive in the rest of the day. I wish you, a good rest of the day. Thank you for being here. Bye.
Thank you. Bye.
Thank you. Bye.